Okay, I think we'll get started. As usual, I'm recording this, and I'm always a couple of people coming a little later on in the session as well. Um, but not a problem at all. Now, if you remember last week, we were working on this part, and I showed the first operation of machining outside. And if you remember, we had my stock over here, okay, which is basically around the part. And that's how my stock is. That's how I define my stock according to my home position as a box around it. And then when I machined it, I got a tool pass that looks something like this with a lot of material removed here. And then someone asked the question last week. And after that question, I realized I answered the question also. The question was, why do I have my stock so large around the part in these corners? Why don't I just turn the part? Turn it so I can have my
Yes,
stock differently on the part itself.
rotated.
And I
Yes,
did answer
exactly,
the
rotated.
question, saying that all I have to do is turn my home position 45 degrees, and my stock will be better placed for this type of part when it comes to the actual machining in a machine shop. That's how it would be. That's how it would look better. What I realized also at that point is that there are some of you that may not know how to take your home position and just turn it to a specific direction. So I just want to take a few minutes showing that, and then we'll go further on in the lesson itself. So as you see right now, my home position has the part like this, where the X is going in this direction and Y going over here. And what I'd really like to do is I'd like to have my X direction going slightly different with a 45-degree turn, so it'll look more like this. So my stock, so I have my X going in this direction. So my stock will actually be a lot more efficient for machining wise. Now I'm thinking about it as a machinist. So how do I do that actually? So let's go back into creating my coordinate system. I'll go to my coordinate system manager, okay? And I'll go and edit my home position. And to edit the actual position itself, we have here edit coordinate system. Now I'm going to create my coordinate system again by selecting my face, and I'm going to have it at the top center of the model box, and I'll click on the part exactly the way I have it right now. That's the way I got it originally. But now I want to turn my home position by 45 degrees. Okay? So if I go further down, you'll note I have modify by flip. I can move it by specific delta. And we also have modify by rotation. And as I said, I'd like to rotate it around my z-axis, okay, around my z-axis that you see over here by 45 degrees. So I'll go into this over here, modify rotation by rotation on z, and I'll write in here 45 degrees. Look what happens over here when I leave that field. My home position, you can see it actually, is going to be rotated by 45 degrees. So now all I need to do is just accept that. And what we have is, if I take a look now at my top view, you can see my part has been rotated. Okay. Now, if I take a look again at my stock, okay, my stock now has also been updated as being, as I did have it as 2 millimeters around the part. So now, since that changed, my stock was automatically updated as well. And now I have to just recalculate this operation. So when I recalculate the operation, you'll see Okay, because I've been fooling around with my parts over here. Let me just go back in here for a moment. Just have to redefine my machine because I moved to a different database. Let me go to my global that I had. There we go. Okay, now I'll recalculate everything. And what you'll see is that my home position, my toolpath is now completely different. There's a lot less material around. So this is a lot more efficient. Now, this has nothing to do with the machine, the way, it's not that we did anything wrong before. Okay, we did it worked exactly the way it was supposed to. But now I just um, repositioned my part on the machine so it'll be more efficient with the type of material that I may need. And therefore, as you can see, my cut is a lot different. Okay, so it cut a lot less than we did last time. Okay, if I don't remember who asked the question, that particular question last week.
It was me. It was
Um,
Yossi because now
but
the time machining is
that is the
shorter and the
for that.
yeah.
Okay.
Thank you very much.
Now, I'd like to open up a different part, and I want to present a problem by when you start machining this. Okay. Now, this part that I have over here, just to symbolize specific problem that we may have, is as follows. You'll note we have our stock around the part sitting on a fourth axis over here, and I have to machine this floor over there, and then afterwards I'm going to flip it around and machine the flip side over here. Not a problem at all. Okay, so obviously I'll need two different home positions, and I already have defined Mac 1 position 2 and Mac 1 position 3. It's the way I want to have it on the machine. Okay, sorry. And I'm going to create my first operation. Okay, now I'm going to create my operation of iMachining 2D, and just to show you also um, a little more about working with chains instead of faces, even though I normally would work with faces, but just to show you also the options of working with chains itself, I'm going to use the option of feature recognition by chain. Okay, I'm going to choose the home position. I want Mac 1 position 2, so I'll go over here. You see, I have my different Mac positions. I want Mac 1 position 2. That's the one I want to work with. Okay, and I'm going to create my geometry. When I create my geometry, I'm going to pick the chain. Okay, basically when I pick this chain, it's picking the entire chain around that floor over there. Now, when picking a chain does not recognize what an open edge is. Okay, and this is a general issue, by the way, nothing to do specifically with iMachining. Any pocket operation, if you pick it with a chain, you have to tell it afterwards what are the open edges. So how do I tell it what the open edges are? If I right-click on the chain itself, we have Mark Open Edges. When I click on Mark Open Edges, I can mark each one individually. Okay, single entity. I can start picking each one individually, or in this particular case, I can do it a lot easier. We have what we call from to. Where do I want to start from? I want to start my open edge from here. Okay, so I'll click on that line, and I want to go up until where? Up until that edge over there, and I'll accept that. Okay, so you can see now where my open edges are, from here to there. Okay, so now I have my geometry. I'm going to choose the end mill I want to work with. I have here a 10 millimeter end mill. It's exactly enough for what I need right now. Okay, I have my levels are all set. My technology wizard. I'm actually going to leave it at 3 because, like I said, sometimes when you're looking at the machine or at the setup that you have, you may say, you know what, this is not exactly the most sturdiest setup because it may have vibration at the end. So I'm just going to leave it at machine level 3. Okay. Now I'm just going to do. You see, it goes by technology. By the way, there's nothing that I really have to do over here. I'm just going to leave it exactly the way it is. Save and calculate. And I want you to take a look at the toolpath itself, and then we'll do the simulation. Okay, let's do a top view. And what you see is that we have a separation moat between the wall and this area over here. And then it does a morphed spiral towards the middle. If I run the simulation, you'll be able to see it a lot better. Using Solid Verify, you'll see the following. It creates the moat that I talked about around the part, around between the wall and the rest of the material, and now it's doing that morph spiral around it. Okay, because we know the spiral is the most efficient way of cutting, and we talked about this last week. In order to do, however, a morph spiral around this, we had to first create a channel or a moat, as you may have it, to separate that area so we can work around. Okay, that's excellent. Now that worked out fine. I want to do the flip side. Okay, so I'm going to take away the marks. I'm going to create another iMachining operation. This time, I'm going to use, again, I'll use the same method as before, but I'm going to use this time Mac 1 position 3 because I'm clicking on my home position related to this side. If I click over here, you can see this is the side that it's going to machine. I'm going to choose my geometry. I'll do it again the exact same way. Pick the chain. You notice it cleared around the entire area over there. Okay? Constant Z, which is constant Z, no problem. I'm going to take that chain again, just like I did before, mark open edges. Again, I'll use from to. I started from here, and I'm going up to this edge over there, and I'll accept that. Okay. And basically, I'm going to be doing the exact same thing I did before on the flip side. I'll use the exact same tool, because in essence, I'm really doing the exact same work from one side to the other. Okay? I'm going to leave everything the exact same way. I didn't touch really anything over here. Save and calculate. Now, let's take a look at the simulation the moment this finishes. You can see right now we're getting the exact same toolpath. Okay? Let's run the simulation. Solid Verify. And if anyone picks up what the problem may be on the machine, you can go out and shout it out as I'm running through the simulation. Okay? It's machining now this channel over here, exactly the way it did before. Let me stop. Does anyone see what the problem is on the machine?
It's a chattering problem, no?
Excuse me, go ahead, I'm sorry.
Your conventional milling.
No, that's just because of the amount of seeds. It's going fine. Not conventional meter. It's actually doing the. I'll slow it down.
Oh, okay.
It's doing.
I see
It's
it
doing the. What's the problem here?
It's climbing. Sorry.
It's climbing. That's not the problem. The problem is like this. This is on the machine right now. Okay. This floor, once it flips around, becomes.
There is a vibration problem, no?
Yeah, exactly. Exactly.
Got rid of most of the material.
Right. Exactly. Because this floor is so thin, once you cut away that material, there's practically no support over here. So you're going to have vibration on that floor. No matter how you cut it, you're going to have vibration on the floor. So what I have to do is machine it without having that channel over there. Machine it a little differently. So how do I do that? Okay. So let me go out of the simulation for a moment. Okay. And let's go to our technology. Now, remember, this is a channel. Okay. You see, we have here at the top, it says technology, and we have here channels. Let's go into our channels field for a moment. You'll note it says something called island moding. Okay? In other words, creating an island by creating this mode over here. It's on by default. If I turn it off by default, if I turn it off, not by default, but I turn it off, let's take a look what happens now. My toolpath will be completely different. True, I won't have the spiral cut, but I'll have the trochoidal iMachining cuts on the part itself. Let's take a look now at the simulation using Solid Verify. Okay. And this time what you'll see is a little different. Okay. And it's moving around instead. So you always having this basic block over here still has this full support from the back over here. Let me stop it for a moment. Let me go a little slower again. Okay, you see right now it's jumping up. I'm going to go a little further on. Okay, and go a little slower again now. Now, let me do it one step at a time. You see now when it gets to a place where the jump over back to here is short, it doesn't jump up anymore because it sees that the tool, it's a lot quicker just to go around it rather than go up, back, and down. So we also look at that when we're doing it. Now, what you see basically over here is that it kept its support from the back as much as it can. Okay, so these are little tricks that's good to know because, you know, I can put a tool pass in it, it really looks nice. But I come to the machine, how do I work? What do I do when I have a situation like this? When I have too much vibration? Or for whatever, if I come to an area in any kind of machine that runs into this kind of a problem, thin walls, and it wants to do that moding, I can easily turn off the moding option and work this way. Okay, are there any questions about this? Okay, not a problem. You can just we note that we have that as well. Okay. Now, let me also just do one more thing. I'm going to run the simulation on the very first side without the Solid Verify, the regular simulation. Okay, let me go all the way to the end. I want you to pay attention to this. You see it out on the opposite side over there. This was 3 minutes and 14 seconds. Okay, I'm going to do the simulation now on the flip side. Sometimes it's even faster. Okay, so it's not always.
Sorry, Sydney, I have a question.
Sure.
I just, maybe I forgot, maybe you explained it, but I want to understand. I have a model, for example, of a part similar to this, and I want to install the part in a picture on a device like this, like a 5-axis machine or
Okay.
device like you're showing right now. How I can do it, because I didn't achieve the result to do it by myself.
All right, that's a little more with that has a little more knowledge with SolidWorks itself more than anything else, because that has to do with creating an assembly and then mating it correctly. Okay. I can show it to you very quickly. I don't want to ruin this part, so what I'll do is use the option Save As. Okay, that's why I part Save As. Oh, went to my other screen. Sorry. I'm going to call this 2. This way I don't ruin my original part. So now it's closing my old part and it's loading. It's going to load up the copy I just made. Okay. And what I'm going to do here, just to show you what I did this, I think this is worthwhile. I'm going to delete everything in here. This has nothing to do with it. Okay. I'm going to go in my CAD tree of SolidWorks. You'll note I have my design model, which is that. Okay. Oh, and then I have my second part, which is my fixture. And I have my screw, which I have in the back here. I was really being trying to make it as much as convincing as possible. Okay, in any case, let me go into my mates. Okay, first of all, you know how to bring in components into an assembly? Who asked the question?
Into the CAM, but it's Yossi.
Okay. So I'm going to get rid of all of these options that I have over here, all these mates. Okay. Okay. So right now, if I take this, let me see for a moment. Okay. Why is it full defined? Okay, let me just go over here for a moment. Because I defined it inside the inside here. Okay. You know what? I'm going to do something very simple. I'm going to take this. I'm going to open it. And I'm going to save it separately. And I'm going to call this Fixture. Okay, I'm going to put it in a specific area where I know they are. Okay, this is just for my own knowledge exactly where I put things. Okay, I'm going to call this Fixture Sample as a part. Okay. I'm going to close this now. I'm going to take this, what I have here, and I'm going to remove it from my assembly. It doesn't exist. In fact, this screw head over here, I'm going to remove that as well. Okay, I don't need it. Okay, I'm going to delete that as well. So now this is the way I'm starting off my work, correct? All I have here is my design model, okay, and nothing else. Okay. Let's go now into my assembly, and I'm going to insert a component. And the component I'm going to insert is, where are we? Fixture sample 1. Okay, that fixture. Okay, and it comes in floating like this. I'm just going to put it anywhere right now. Okay, this is how my fixture looks. Okay, now this is how my part looks also. Okay, now I'm going to do the following. I'm going to create mates. How do I create the mates? I'm going to what they call mate. Okay, right now this is completely free. Going to mate, and I'm going to say, let's take this circle over here. Sorry, let's see, mate selection. Okay, there we go. That face over there, and it'll take this. Sorry, no, that one was not correct. Okay, I'll just delete that one. I'm going to say this circle inside over there, and I want to make it concentric. This is not good. I'm just going to flip it. Okay, I'm going to do the same now. I'm going to accept it. Now I'm going to continue. I'm going to say, I want to take this over there and this, and I also want to have it concentric, and I'll accept that. Okay, next I'm going to say I want this floor over here and this over here to be coincident. Okay, accept it, and you can see now everything is in place.
Thank you very much.
Okay?
And did you get that screw out of your toolbox? Is that where you got that out of?
Yeah, I took it from the toolbox of SolidWorks.
Okay.
Okay. So that's not a problem. Okay, so we deviated a little bit from what I was trying to teach today, but I have no problem showing it because this is also important because sometimes you want to work with the program as well and doing these things. So I deviate a little, but I have no problem with that. Okay. Okay. So okay. Now that I defined this, by the way, let me go back into here. Okay. Let me delete what I had here. I'll show you just in a moment what I did there. Okay. I have to create my fixture setup. Okay. Because if I were to do simulation now, I wouldn't see the fixture. I never define. I have to also define in SolidCAM my fixture. So how do I do that? First of all, I already have one here from before. I'm just going to get rid of it, delete, because it remembers what I had there before. How do I create my fixture? There's several ways. The easiest, I can create it over here, but this is not the right place to correct it. If I right-click on operations, we have here something called machine setup at the start of the tree. Okay? Where I am right now. Right now, you see, there are no fixtures here. If I were to open it up, you see there's still no fixtures there. Nothing fixtures on it. No fixtures are being used. So I have to create one. How do I create it? I can go over here, new, and click on the part. Okay. I can even do show even to show that I picked it. You can see my fixture, so we recognize it, and I'll accept that. I'll say okay. Okay. So now we've defined our fixture. And then again, now I can continue with the part. I can continue with the, the usual iMachining just like I did before, or any type of machining I want. And I can do the exact same thing I did before. Choose my geometries. Okay. I open edges. Again, from 2. Accept that. Choose my end mill, just like before. There's nothing is here, but I still have my tools. I did copy paste from before, and I didn't erase my tools, so I still have my tools from before. Okay, and I'll just do save and calculate. Okay, and again, now if I run my simulation using Solid Verify, you see everything exactly the way it was before. Okay, now had I not defined my fixture, I would not see this here. Okay. Any other questions before I continue? Okay. We talked a lot about iMachining 2D. Okay. Let's talk a little bit about iMachining 3D. Okay. iMachining 3D can be used on different types of parts. Okay. One, let me open up a different part. I'll go to open. And let's see if I have something good over here. Okay, no, we'll go to a different area. And go back to open. We'll go to here. And we'll go to iMachining 3D. Perfect. Excellent part. Okay, let me just get rid of what I've done over here. And I'll suppress it. Okay. Let me see if I have my stock here. Okay, here I didn't physically create a stock. I just did a stock. They did a stock over here with a simple box around the part itself. Okay, there's their stock over there. Okay. Now, iMachining 3D is a roughing operation. Okay? Only roughing operation. Okay. Now, I'd like to machine or quickly machine or roughing this part over here, as you see over here. Okay? Now, when I go to, let's go to SolidCAM 3D, where I have my iMachining for 3D. Another way to find this, by the way, iMachining 3D, is I can go to regular SolidCAM operations, click on iMachining. I have here both 2D or 3D, or I can also right-click on operations, add operations, 3D iMachining. Any way you want, you can have it. Okay. First thing, you'll note the geometry is automatically put in here as the target. Remember, when we create our part in the beginning, we always create our target. We have our target is automatically put in here. I can choose something else if there was a reason to, but in most cases, I don't. If I click on show, it shows you exactly what the target is. Okay. We'll go into this a little later on. I'll choose a tool. Now this works with multi-tool only. I can have since it's only roughing, okay? So I can do several tools in here one shot. I'll select my first tool that I want, the tool that I want to use, and I'm going to use my 2mm, my tool number 2, bullnose tool. Note it's a 12mm tool with a little bit of a corner radius, 0.6mm radius on the tool. Okay. Okay. Also note, if I click on tool, I'm going to choose, I can choose holder collision protection. Okay. Now, levels, I'm going to leave it exactly the way it is up until the bottom of the part. Okay. My technology wizard, in this particular case, it's defaulted at 6. Okay. And my technology, let's go through my technology now. Okay. We have here our wall offset, floor offset. And I want to go into this area right now. There's something here called rest roughing, and I'll explain in a minute what that is. And on purpose, I turned it off for now. Okay? Now, what's going to happen? I have my levels, my technology wizard, sorry. You see it wants to go down twice. Okay? Let's see what happens when I do save and calculate. Okay? Now, the calculation over here takes a little longer, and because it's actually parsing at each level that has to go down and see what the geometry is on that particular level. Okay? Now, what do you see here? Let me do a simulation. Go to Solid Verify. Okay. And let's do this slowly in the beginning. You'll note it's going down its full step over there. Okay? And that's all it did. It couldn't go down further because going down further would crash the holder into the part itself. Okay. Not a problem. Now, all right, this looks really good, but it really didn't do anything. What did it do? Just milled around here. What about all this area over here that I had to machine? Okay. So now, remember I told you I went into technology and with something called rest rough. Okay. I'm going to turn on the rest rough. Now, you'll note the rest rough next to it, it says also step up. The way it works is very simple. It first goes down as far as it can, and then, before continuing, it steps up on the part. As it steps up, it clears material, and as it goes up, there's less and less material to be machined. Okay? How much of a step up is it going? You'll note we control it by what we call a scallop. Okay? If you take a look at the picture at the side over here, we say how big of a scallop do we want? And it'll automatically give you the proper scallop according to the actual angle of the material. At a steeper area, the scallop will be bigger. Shallower areas, there will be more scallops. Okay? Now, 1.98 you may say is a little big. Not a problem. You can always change it to exactly the way you want. I'm going to do it right now at 1 millimeter, my scallop. Okay? Now, this takes obviously longer to calculate because not only does it have to calculate the side steps over here, the first step, and now also has to calculate this area over there, has to parse that as well. So this does take a little longer. Give me a chance to drink some water. Okay. Right now, immediately you can see that it went further down. And let's take a look why. And it also has these step-ups now over here. Let's take a look exactly what happened. Run my simulation. Again, I'm going to use Solid Verify. Okay. Now, again, it's doing the first step over here. Now, I just want you to note before I continue, you see this holder? If it goes up further over here, normally it would clash into this area. Keep that in mind. Okay. What's happening now, it's starting to step up on the part. You see, it cleared off this area over here, giving me those step up that I was talking about. You'll also note, I'll stop this for a moment, that it tries to, it didn't go around here and jump around the part. It worked its way up and then it continued over here. So it tries also to keep itself in the same area as much as it can. Okay. Now you see it's stepping up over here, going further and further up. Now note, the fact that it's going further up over here, that means there's less material now for it to take away. So it doesn't always have to start from the outside. If I would be stepping down, first of all, I would be cutting with a small amount of the tool. Stepping up, I'm cutting this whole area over here. Okay. Let me go further. Okay, now you can see also over here. Here's a very steep area, so you have less steps, barely any. Whereas over here, as it gets more of an angle, you get more and more steps. Now, okay, that's because it crashed into my thing. I forgot to take this into account with my depth. All right, that's a different issue. But let's continue. Let me stop it for a moment. Now look at the side over here, okay? You can see now, here's my holder. This is why it could not go all the way down over here before. Because before, it didn't do the step up before, so my holder would have crashed into the stock that was left over there. That's why I couldn't do it. Now that I've cleaned this area away, it can continue machining over there as well. Okay? By the way, how do I avoid this? Going down like that? Just limit my depth. In this particular case, my level, I'm just going to have it go to the bottom of this. Okay. Give it another 0.5 millimeters. Save and calculate. And again, you'll see it will be a little different now. Let that finish. But you understand now how the step up, what's the issue with step up? Why do we have that step up? Instead of going, first of all, if I would go down from the very top, from the very beginning, you'd have a lot more material to review. And we notice you do the step up in between each step. Okay, I did the first step down, I did step up. Then I did the second step down. Okay, had I did the first step up, if I did the first step down, and then the second step down, I would not have been able to do the second step down because the holder would have gone into material that was over here. That's why we do down and then up. Finish that, then we go to the next step down. And again, running my simulation, I'll do it as quickly as I possibly can. Okay. Okay. By the way, if anyone has questions while it's going over here, feel free to ask.
What's the time on that? How long did that take to do?
It depends on the material, obviously. I have it set pretty fast right now. So right now, you can see the time over here.
Oh, okay.
I don't remember what material I used in here, but I believe probably aluminum. It also depends on the size of the part, the type of material I'm using, also the machining level that I'm using also affects the time. Those are factors that affect the time. Okay.
Yeah.
Okay. So we have that now. One more thing I'd like to do. Remember, I said this. Let me before I remember this is in each operation I can have more than one tool. Now, you note that it worked over here, but because it's a pretty large radius tool over here for this part, there's too much material still left over here to start gluing a finish. Okay, so what I may want to do is use another tool that's smaller to work just in those particular areas. Okay. What do I do now? I'll go to my tool, okay, to my multi-tool over here, and I'll select another tool. And this time, let me get rid of this over here. I don't need to see this. I'm going to use this tool over here. Was that the tool I wanted to use? No, I wanted to use this one here. There we go. 6mm ball nose tool. A lot smaller. Okay? Except that tool type is incorrect. Shouldn't be. Okay? All right, playing games with me over here. I'll show him. I'll just create a copy of this tool. I'll have this here as 6mm. Okay? I'll have the radius over here as
Radius 3.
3. There we go. Okay. Levels, I'll keep that the exact same thing. Oh, wait, the level, it's right, the same operation. Now you'll see now this, I'm in tool 1 over here. If I go to my technology, I'm going to have my scallop a little different over here. I'm going to have my scallop at, say, 0.5. Smaller. Now, I could have done 0.5 in the first one, but there's no reason for it really. Okay? Because I first want to get most material away, and then I'm going to use this to finish up. Okay? I'm just going to do save and calculate. Okay. Now created the second operation. It's, you see now there are two operations here. That's calculating the second one. It's updating the stock for the first one. This may take a little longer because there's a lot more steps involved over here. Now, while it's calculating, let me ask a question. Let's say I had a prismatic part, not a mold part like this, but a prismatic part where you have all the walls are 90 degrees and 0 degrees, basically a box type of thing with a whole bunch of different pockets. Okay, and I'm just doing I just want to do one part just to see how it works out. Would I use this iMachining 3D to machine out those pockets?
I would say no. Because it's going to want to do the whole part.
No, I do want to do the whole part. I'm saying I want to.
Oh, I thought you said one pocket.
No, I want to do all. I have a whole bunch of pockets. I want to do all those pockets.
All right.
So I think you answered the question when you realized I was talking about all the entire part.
Yeah.
So in that case, since I'm not really interested in individual control and stuff like that, I would definitely consider doing all my roughing operations using iMachining 3D. Okay. Okay, we're almost done. I hope. Yeah, it looks like it's going. Okay, it's worthwhile actually seeing what this happens. So that's why I actually put a I put a 0.5 millimeter scallop, right? As you can see over here, my scallop is a 0.5 millimeter, which is a pretty small scallop. That's why it's also taking a lot longer.
It's still big,
Yeah.
Depends the area that you want to achieve.
True. But when you're talking with a ball end mill, it's a lot smoother for then you do semi-finish and then you finish cuts with the different options in any case.
Yeah, but you're using a ball 6 after diameter 12, so you need to consider that you have another 3 millimeter per side for the bonus operation now. Because if you're going into the corner over here,
well, we'll see. We'll see exactly what happens.
Yeah.
Okay. Okay. First of all, you can see obviously it's only working around the areas over here. It's not working at all over here. Maybe certain corners over there may be working over there, but really didn't have to over there. Okay. Maybe a little bit of an edge over there that because of the scallop I gave may work down there as well. I could have also limited it if I want to only go to a specific depth in this particular operation. But let's take a look now at the simulation. Okay. And I only want to look at the simulation of the second one. So I'm just going to click on this one, not highlight the first one. And just click on this once, and it'll automatically update itself. So we can see exactly what's going on. Right now, the stock is updating itself. This way you can see the simulation also correctly. Now, this is basically done once when I machine the thing, and after that, it remembers it and starts for the simulation. Okay, so this is how my part looks now. And when I machine it, by the way, I could have also, if I wanted to, I could have said, no, could have basically left the way it is. Like I said, I could have limited it just to go down to this area over here. Okay, since I wanted also, again, smaller steps, that's why it's working over there as well. Now, you note that the simulation's going not as quick as you'd like it, even though it's a figure. That's because since this is a ball nose, the rendering of the part itself does take longer than if it was a straight end mill. Okay, so
There's
that
a
does take
1,000 point to calculate. Yes.
yes, exactly. That's why it's going a lot slower. Okay, uh, there is one trick for making it go quicker. I'll stop it for a moment. We have here something called turbo. When I work it on turbo, you'll note this is moving, this is not. Okay? If I click on the part, it updates itself as it's going. Okay? This way it doesn't have to render itself every single time, all the time as it's working. But it's still moving. Okay. Now, before I
But if
finish,
you have a better graphics, if you had a better graphics card, it would render it quicker, correctly,
well, my graphic card is pretty.
correct?
It's pretty good. My graphics card actually. I think it's a Quadro 4000 something. I forgot which one it was exactly.
Okay.
But yeah, obviously the bigger the graphic, the better the graphic card, the better it'll work. One thing I could also do was where was I? Yes, if I go, let me go out of here into a different mode for a moment. HostCAD. If I wanted to continue working, okay, right now as it's doing simulation, I can't continue working, right? Obviously. What I can do is I can go out of my simulation. Let's go out of here altogether. And let me see what I can do over here. If I highlight both of these, I'm going to right click over here. And let's see what some of the options we have here. We have here we have calculate in parallel. Let's do this. We have here SolidCAM simulator. This is actually a pretty new simulation mode. Okay. If I do SolidCAM simulator, okay, we have it as a separate window over here. Okay, I'm going to let it run. Now, while this is running, okay, I can continue working. I can go over here, create more operations, and do whatever I want to do. Okay, so I don't have to stop. I can put this off on the side, let it run, and continue working on the part, even though the simulation is still going on. Okay, so if you run into the question problem, you don't want to keep on waiting all the time for the simulation. You can always do it externally, or I should say, you can always do it using the new simulation that we have as well. Okay, that new simulation is called SolidCAM Simulator. Okay, right now it's in beta, but it's not going to be. It's not really beta anymore. It's practically finished, and it is available for everybody to be used. Okay, we'll talk about this a different time about this actual beta, about this particular simulation. Okay, I'm gonna close it. We're done. Okay, that is all for this session, and for our next session, of course, I'll give you exact time when we'll have it. It will probably be not next week, but in 2 weeks from now. Okay. I want to ask just a general question. Is Tuesday a good day? The way I have it right now, is that a good day for everybody?
Yeah.
Okay, and I think the action was going to be yes, because I see there are a lot of people. Almost everybody is basically inside the session as well. So that means the Tuesday actually is good. Okay, all right. So again, this has been recorded. I'll send a recording out to everybody. And again, if there are any particular subjects you want to cover, okay, that I've not covered yet, or you want to clarify any type of area in the program that we covered already, but you want to go over it again, let me know. You have my email, and I will be happy to go through it with you guys as well. Okay, take care, everyone.
Thank you, bye.
Yeah, thank you.
Thank you, Sidney.
Thank you very much. Here.
My pleasure.
Bye, Sidney.
All right, take care,
Thank
everybody.
you. Thank you very much. Very useful.
You all right? Bye bye.